A steady supply of chromium, vanadium, molybdenum and niobium is a key strategic asset for the European industry. These metals are fundamental for the competitiveness of manufacturing and for the innovation potential of high-tech sectors. Chromium, for example, is a key element in metallurgy. It can provide resistance to corrosion and a glossy coating to several materials, among many other applications. Unfortunately, the European Union has to import 45% of all the chromium and 100% of molybdenum, vanadium and niobium needed by industries across the member states. At the same time, significant amounts of these metals are entrapped within industrial byproducts such as slags. The CHROMIC project aims to unlock the potential of these resources by developing new technologies and processes to recover these four elements from industrial byproduct streams. Valuable compounds which are left in the slag will be turned into raw materials that can be reused as input flows in production processes. This way, Europe's raw material supply can be diversified. At the same time, the sustainability of the metal industry will improve and its environmental impact will further reduce. The CHROMIC project's network involved 5 research centres, 5 industrial partners, and 1 university from 5 different European countries. Belgium-based research centre Vito acts as the project coordinator. The CHROMIC partners have combined new technological innovations with well-known industrial methods in a process to extract chromium, molybdenum, vanadium and niobium from the slags in a sustainable way. The first step of the process is pre-treatment. It uses innovative systems including microwave ovens and electrodynamic fragmentation to assure a more efficient and tailored physical liberation of the valuable parts entrapped within the slags, so that they can be more easily separated with state-of-the-art sorting techniques. A second step considers different options for highly selective leaching. In other words, it specifically dissolves the valuable metals from the material in a water-based solution without unwanted dissolution from the main bulk of the slag materials. Given the relatively low concentrations of the target elements in the slags compared to the primary ores, highly efficient and selective leaching is needed to obtain an overall economical process. The solutions containing the dissolved metals, called leachates, are further processed in a third step by highly selective recovery processes to concentrate and purify the valuable and critical elements and finally to produce marketable products. Additionally, it is essential that the residual material continues to meet the criteria for use in the construction industry. At the end of 4 years of research, promising metal recovery techniques have been identified and selected. At the pre-treatment stage, a 3-fold increase of chromium concentration compared to the original material was obtained through a combination of magnetic and density separation techniques. For the selective leaching, it was found that roasting with sodium chlorine followed by water leaching can extract more than 95% of chromium and 33% of vanadium. Finally, in the recovery step, several methods were combined to separate valuable elements from impurities in the solutions. For chromium recovery, the entire flowsheet has an overall efficiency greater than 85%. By recovering the inherent metal value from secondary resources, CHROMIC facilitates sustainable materials management and a reduction in primary extraction. The CHROMIC project has contributed to set the way towards the realization of a circular economy for critical raw materials, which has the potential to bring significant economic and environmental benefit to the European society.